I want to review before we get started on getting the common denominator. If we were given this problem right now, we'd be able to look at 4, look at the 6, and we'd be able to come over here and say, yep, multiply times 3, multiply times 2, recognizing, okay, that gives me 3 over 12 plus 10 over 12. If we were working with just basic integers, this could be very simple, but I want to look at with prime factorization because when we look at polynomials, it won't be as easy as multiply by 3, multiply by 2. I want to look at the prime factorization again, those number trees. 4 breaks down as 2 times 2. 6 breaks down as 2 times 3. Now, what I want us to think about, and it seems silly with integers, but if we look at what's in common, what we really want to look for is what's missing. Because if we fill in what's missing in each denominator, then we can get them to be the same. Like over here, I have 2 2's, I'm missing a 3. Times 3 times 3, that's where that 3 comes from. Over here, I had 2 2's, over here I only have one of them. So if I multiply times 2, that's where that 2 ultimately comes from, is kind of a what's missing is what I like to think of with rational expressions. And you'll see with polynomials, this is going to make a lot more sense. Now notice, if I were to look at the denominator, 3 times 2 is 6, times 2 is 12. 2 times 3 is 6, times 2 is 12. That's where that 12 comes from, is by looking at what's missing and multiplying by it. Once we have a common denominator, piece of cake. Add the numerators, 13 over 12. I'm good to go. And even at this point where I may need to turn things into mixed numbers, I may have an improper fraction. With my polynomials, I won't see those. But what I want to look for in my next few examples is that what missing is what's going to give me the common denominator.